Hello everyone, myself Dr. Pranesh, Assistant Professor, Department of Mechanical Engineering, Sri Ramakrishna Engineering College. Today we are going to discuss on the topic resolution of forces. Before entering into resolution of forces, we will see what is meant by statics and what is meant by force, what are all different types of forces, and then we will move on to resolution of forces. First, statics. Statics means bodies at rest. Simple manner we can say bodies at rest. But as a definition, in statics the object does not move because all the forces acting on it are balanced. What is meant by balance? Consider an object. Due to self weight, the force will act in the downward direction, that is due to gravity. We are mentioning it as weight. So this force is acting downwards. In order to overcome this we can call it as action also. So opposite to this action is normally reaction will takes place. If these two forces tends to balance, then the net force will become zero. That is a simple definition for statics. Now next to statics. In statics, force plays a vital role. What is mean by force? Either push in this direction or you are pulling in this direction, both tends to force. A force is push or a pull. Under the system of forces, there are different categories. First category is coplanar and number 2 is non-coplanar, broad classifications. Under coplanar, number 1 is collinear, 2 concurrent, 3 parallel and fourth one non-concurrent, non-parallel. Under non-coplanar, number 1 is concurrent, 2 parallel non-coplanar forces, number 3 is non-concurrent, non-parallel, non-coplanar forces. We will see one by one. What is mean by coplanar forces? The forces whose line of action lie on the same plane. For example, only one plane, we can call it as, that is only one plane. All the forces acts on the same plane are known as coplanar forces. If it is more than one plane like this, it is called non-coplanar forces. So non-coplanar forces definition, the forces whose line of action do not lie on the same plane are known as non-coplanar forces. Next is collinear forces. What is mean by collinear forces? The forces whose line of action lie on the same line. For example, consider this. All the three forces acts on the same line. Irrespective of direction, you just see all three forces acting on the same direction, same line. It is called collinear forces. If this can be splitted into two. One is like collinear forces. If all the forces are acting in the same direction, we can call it as like collinear forces. If one force is acting in this direction, another force is acting in this direction, another force is acting in this direction, we can call it as unlike collinear forces. And the next is concurrent forces. Concurrent forces. What is mean by concurrent forces? The forces which meet at one point, that is this point O. The forces which meet at one point are known as concurrent forces. The concurrent forces may or may not be collinear. Next is coplanar concurrent forces. We know about coplanar and we know about concurrent forces. Now combinedly, the forces which meet at one point and their line of action lie on the same plane. In a single plane means we can call it as coplanar concurrent. If the forces which do not meet at one point but their line of action lie on the same plane are known as coplanar non-concurrent forces. And now next is non-coplanar concurrent forces. The forces definition we'll see first. The forces which meet at one point but the line of action do not lie on the same plane are non-coplanar concurrent forces. We know that coplanar means single plane, non-coplanar means more than one plane. So non-coplanar concurrent forces like this. This is plane 1 and this is plane 2, non-coplanar. Concurrent forces which meet at one point but the line of action do not lie on the same plane. Next, non-coplanar, non-concurrent forces. Non-coplanar, okay, you just see non-concurrent, two forces are acting in the different direction. So, the definition is the forces which do not meet at one point and their line of action do not lie on the same plane, that is non-coplanar, non-concurrent forces. We will see one example with respect to collinear forces. Consider a force of 8 Newton acting in this direction, okay, and 10 Newton is acting in this direction, 12 Newton is acting in this direction. So, before going to solve this, first we need to consider the sign, whether I need to consider this right to left acting force is positive or negative. It is depending upon the cases. First, you can consider upward force is positive, means like this, downward force negative, horizontal force left to right is positive, horizontal force right to left is negative. So, according to this, suppose 8 Newton is acting from right to left, here you can consider either negative or positive. Any one condition you need to follow. If you are following this, that is fine, or else in the vice versa opposite direction also you can consider upward vertical force negative, yes, downward vertical force. If suppose this is negative, you should consider this as positive. If suppose this is positive you are considering, or if you are considering this as negative, another one you should consider as positive. Either vice versa you need to consider. First case, find the resultant force of the collinear forces shown in figure. So, 3 forces are acting, 8 Newton, 10 Newton and 12 Newton. How to consider this? So, the final thing is 30. You all will know that the forces 8 Newton, 10 Newton, 12 Newton, everything is acting in the same direction, collinear, same line. So, what we are doing? 8 plus 10 plus 20. So, we will get the answer as 30. But one thing you need to consider here, in this case, all the 3 forces are acting from right to left. According to this, right to left is negative. So, in both the way, either you can follow this or you can follow this. Both the conditions we have mentioned here. Okay. So, either you can mention as minus 30 or plus 30. This minus indicate the force which is acting in the direction. Only this is denoted for the representation of direction. So, the force 8, 10, 12. Finally, you will get the answer as 30. Either you can follow this or in the vice versa manner, vice versa method you can follow this. And another one. So, you just see this, find the resultant force of collinear forces shown in figure. Here 2 Newton is acting in this direction, that is left to right, and the second force 3 Newton is acting from right to left, and the third force 6 Newton is acting from left to right, and fourth is acting from right to left 11 Newton. So, how to find it? According to the previous case, suppose I am just considering left to right is positive, right to left is negative, upward force is positive, downward force is negative. Suppose if I am following this case, what will happen? 2 minus 3 plus 6 minus 11. This is how collinear we need to find out. Okay. So, the final thing is answer we will get as 6 Newton. How the 6 Newton? So, we already mentioned, that is 2 minus 3 plus 6 minus 11. So, this indicates 6 Newton. So, 2 minus 3, 6, 11. So, this minus either you can indicate or simply you can mention it as 6 Newton and you specify arrow mark in this direction. It denotes the force is acting from right to left. Either arrow you can mention or this sign you can mention. Both the thing indicates only the direction of force acting. Next, Next, we are entering into the topic resolution of forces. Normally, always it is not mandatory that all my forces should act perfect horizontal or perfect vertical. In some cases, my force may act in the inclined direction. How to solve this? That is the method of resolution of forces. The inclined forces, how to solve this inclined force. First, we will see the definition and then we will move on to the example. So, the process of splitting up the given forces, given force, okay, into a number of components without changing its effect on the body is called resolution of force. A force is generally resolved along two mutually perpendicular directions. Suppose if it is of inclined force, the force can be resolved like this. Why we are moving like this? We will see in the example. In simple manner, we can say splitting up a force into components along the fixed reference axis. Now, this is my inclined force. I am splitting this inclined force into two. One is horizontal and another one is vertical. Now, consider a force F which is acting in this direction with an inclination of theta with respect to horizontal. Now, we need to resolve this. So, we saw about resolution of forces, splitting of forces. So, what to do next? So, for my convenience, I am splitting this force into two. One is with respect to horizontal x reference axis and another one is y with respect to vertical. Okay, x and y I am just considering. As usual, my force F is in an inclined manner with respect to horizontal axis theta. I have denoted this point A, and with respect to vertical axis y, horizontal axis x, and this inclined force is F. Now, in order to resolve this force, what I am doing is I am drawing a parallel line from A, one vertical and another one horizontal. So, A to B will be parallel to OY and CA or AC parallel to OX. Initially, I need to construct an image like this. Then, now, this horizontal red line OX denotes horizontal force. So, this F suffix H denotes horizontal force, that is OX. In the OX is the reference axis, in which OB, the line I am representing as horizontal force. OB or CA I can represent. Similarly, I can represent the vertical OY vertical line reference axis, in which I am considering vertical force, that is F suffix V. F suffix V, this F suffix V is denoted by OC or BA. Fine. Now I am considering this OAB right angle alone. OAB. I am just considering this inclination. What will happen? Suppose I am just constructing cos theta. Cos theta is nothing but adjacent by hypotenuse. So, your adjacent is OB. Adjacent is OB. Hypotenuse is OA. So, we will get FH is your OB. Accordingly, we have mentioned. Similarly, OA is F. OA is your F. So, finally, we can conclude FH equal to F cos theta, because FH we need to find out. So, I am just modifying like this according to the case. So, horizontal force is nothing but F into cos theta. Similarly, with respect to vertical, what will happen? FV, that is F suffix V equal to F sin theta, that is sin theta opposite by hypotenuse. Opposite is nothing but my A and B. Opposite, that is sin theta, opposite is A, B, this distance, hypotenuse is O and A. So, opposite by hypotenuse. It gives you, for my consideration, I am just taking it as f suffix v is nothing but f sin theta. Now, just to refresh, first initially inclined force we have splitted into two, OB, OC, then finally we found horizontal force FH and FV. Now, this OB denotes the direction of component. Earlier we saw about magnitude. Now we are dealing with the direction of components, that is OB, OC, that is horizontal and vertical forces. Now, in this, finally we found the horizontal force like this. So, horizontal force is represented in this direction, left to right, and then vertical component what we found is in this direction, green line, f suffix v. Initially we know blue is our force. In order to resolve this, we have splitted this inclined force into two, horizontal and vertical forces. Finally, we need to represent like this, how after finding the magnitude, how my forces is acting. Direction of the component is also necessary to specify. So, FH, in which direction it is acting? We know that in the previous case we saw left to right is positive, right? Left to right is positive. So, this horizontal FH is acting from left to right, so it is positive. So, positive F cos theta. Similarly, positive F sin theta with respect to vertical. Why? This vertical force is acting from bottom to top. So, according to the previous case, we know that forces which is acting from left to right is positive, right to left is negative, bottom to top is positive, top to bottom is negative. So, suppose if we are following this case, this will come. Now, we saw only the one case, but in the application point of view, we saw the forces may act in all four quadrants. Suppose if we are starting from first quadrant, a force is acting in the horizontal force is acting in this direction, that is from right to left. This indicates. So, why? We know that horizontal, this is positive, this is negative, vertical positive, vertical downwards is negative. So, this force is acting from right to left. So, minus F cos theta, and this force is acting downwards. So, minus F sin theta. My force is acting in this direction. Okay. And now, case 2, that is of second quadrant, my horizontal force is acting in this direction. So, positive, acting downwards, negative. Similarly, third quadrant, horizontal positive, vertical positive will come. And then fourth quadrant, horizontal negative, vertical positive will come. So, this, what this says is inclined forces acting towards the point of origin in all the four quadrants. So, the inclined, all four forces are acting towards the point of origin in all the four quadrants. If suppose inclined forces acting towards instead of towards, if all the four forces, inclined forces are acting away from the point, what will happen? Vice versa, all the cases you need to change. That I think you can solve by your own. Now, consider this. We'll see one example where all three forces are acting away from the point. In the previous case, we saw all four forces are acting towards the point, we saw, right? Now, we'll solve one case where all the three forces is acting away from the point. We'll resolve this. Before resolving this case, you understand the cases, that is, this belongs to coplanar in a single plane. So, what they are saying, three coplanar concurrent forces. Okay. So, what is meant by concurrent forces? We know all the forces should meet at one particular point. So, here you just see coplanar, one plane, concurrent, all the three forces are meeting at one point. That meeting means not meeting towards, it is acting away from the point. So, 3 coplanar concurrent forces are acting at a point as shown. Determine the resultant in magnitude and direction. In the previous case, we saw how to calculate magnitude, that is Fh, Fv. Then how about the directions? Now, before entering into the case, first what we did in the last case you need to do. That is, first you need to resolve this case, that is how the forces are acting. First case we will see 200 Newton. This 200 Newton, how it is acting, inclined force. This 200 Newton which is of 45 degree which is there. So, in order to split this force, one vertical and horizontal will come. So, left to right we know positive and bottom to top we know positive 200. Next is of 400 Newton. 400 Newton, how this force with respect to horizontal 30 degree is acting. So, this we are splitting into two, one vertical and another one horizontal, and another one we are splitting as 600 Newton, we are splitting into two, vertical, horizontal. Vertical is because acting downwards it is negative, left to right it is positive. First you should be aware of all the 3 direction and its signs. Next, first how to start this? First we will resolve the horizontal forces. How the horizontal forces? First, how many horizontal forces? This one horizontal force, 2 horizontal force, and then 3 horizontal forces. And how many vertical forces in this? 1 vertical, 2 vertical, and 3 vertical forces. So, 3 horizontal and 3 vertical forces are there in this case. So, first we will resolve the horizontal forces. So, summation of H will denotes, first we will start from here, horizontal positive. So, 200 cos 45, then another force which is acting in the opposite direction of previous case. So, minus 400 cos 30, and then third one is similar to the first case, acting from left to right. So, positive 600 cos 60. If you resolve, you will get the summation of horizontal as 95.01 Newton. Next, once the horizontal is over, in the similar manner we will move on to vertical. How many vertical we saw? Vertical, so 1, 2 and 3 vertical forces. If you see, 2 forces are acting upward and 1 force is acting downward. So, 2 positive, 1 negative will come according to our case. So, first is 200 sin 45 which is acting upward positive. Second is 400 sin 30 which is also acting upward positive, and third one is acting downwards. So, minus 600 sin 60. So, horizontal we are considering it as cos, vertical we are considering it as sin, as you all know. So, finally, if you resolve this, you will get as minus 178.2. Here you just see it is positive and here it is negative. While resolving resultant, I will tell you what to do. Yes. So, resultant we know, if suppose one force is acting in this direction, another force is acting in this direction, we know resultant will act in this direction. Now, we know these 2 forces. Now, we need to find this resultant. So, how to find resultant? Resultant is nothing but summation of h square plus summation of v square root, that is root of summation of h square plus summation of v square. So, summation of h we already found, summation of v also we already found. If you substitute this, because of this square, this is not an issue for us. So, we will get resultant in terms of Newton, that is positive. Why? Because of square. So, you do not want to bother about this negative or positive, whatever you are getting, simply you just substitute. So, that resultant value you got as 201.95 Newton equal to, fine. So, now magnitude we found, that is summation of h, summation of v, resultant. Only thing is, only we left is, we found horizontal we found, vertical we know, resultant we found, but with respect to horizontal, what is its inclination? That alone is missing, that we need to find out. If suppose you found the value as 95.01 horizontal over vertical over, you need to plot for your convenience. Horizontal, perfect horizontal, positive. So left to right I am just marking summation of h 95.01. Similarly, vertical I found as minus 178.2, minus, that is we know minus in the sense my force is acting from top to bottom, that is minus. So in both, so this will come under case 4 we saw in the previous case. So horizontal is in this direction, vertical force is in this direction. So that resultant we found as 201.95. This alpha we yet to find out. This is what I told. So that you can easily understand all the cases with respect to horizontal. So now before entering into this, you should know, in order to determine, yes, if suppose only the alpha is bending, right? So alpha, what will happen? How to find out this alpha? That is tan alpha is nothing but summation of v by summation of h. So this summation of v we know already, summation of h already we know, only this alpha is missing. So with respect to this case, alpha is nothing but tan inverse of both values you can substitute, you will get alpha as 61.93 with respect to horizontal. Now here the sign plays a vital role. Please note down clearly. So use only the magnitudes of summation of h and summation of v, ignoring the sign, because as I told you earlier, sign is measured with respect to the x-axis and is always an acute angle. So we don't want to bother about the sign here, only the values you substitute, you will get alpha value, that is 61.93, 61.93. So now we found all three magnitudes with respect to direction. That is 61.93. Hope you have enjoyed the session with respect to resolution of forces. We started with respect to statics, what is meant by force, different types of forces, and we concluded with respect to resolution of forces. We will meet you all in the next session. Thank you.